Welcome back to the Nocturnal Astronomer. Somewhere above us, a modest world circles a dim red star, catching just enough warmth to keep water flowing across its ground. And we found it without ever leaving home. Let that settle for a moment. Tonight, we drift out to the places where stars offer certain worlds a gentle, careful balance. Not too warm, not too cold, but something closer to just right. We will linger near our own solar system's quiet boundary lines first, then travel further out to distant suns, wondering softly where else water might rest tonight. Let's dive in. Part 1. What makes a world just right for water? Every star, however faint or bright, holds a narrow band of space around it where a rocky world could keep water liquid on its surface. Too close, and heat boils that water away into vapor. Too far, and cold locks it into ice. Somewhere between those two edges sits a gentle middle ground. Scientists call this middle ground the habitable zone, though most people simply call it the Goldilocks zone, after the old story of a girl who tried 3 bowls of porridge before finding the one that felt just right. The name is playful, but the science underneath it is careful and patient. Liquid water matters so much to this search because every form of life we know of here on Earth depends on it. Water lets chemistry move, lets molecules meet and change and build upon each other slowly. So astronomers use it as a gentle, practical marker, a first clue rather than a final answer when they study far-off worlds. The width of this zone depends on the star at its center. The brighter, hotter star pushes its zone further outward, while a dimmer, cooler star pulls its zone in close. Each star writes its own version of just right, shaped entirely by its own particular warmth and light. A planet sitting inside this zone is not guaranteed to hold water at all. It also needs a suitable atmosphere, one that can trap enough warmth without trapping too much. Venus and Mars remind us gently that distance from a star is only the beginning of the story, never quite the whole of it. Still, this zone gives astronomers a place to start looking, a soft frame around an impossibly large sky. Of the countless stars scattered through our galaxy, only a portion carry a rocky world resting in that gentle band. Finding even one is worth the quiet, patient search that follows. Part 2. The long history behind a simple idea. The notion that some part of space might be friendly to water reaches back further than most people realize. Even ancient Greek thinkers wondered whether tiny building blocks of matter scattered elsewhere might someday form other worlds like our own, circling other distant suns. By the middle of the 20th century, that old wandering had grown more careful and precise. In 1953, a physiologist named Hubertus Strughold wrote about a circumstellar habitable zone while studying whether Mars itself might once have held water on its dusty red surface. A decade later, researcher Stephen Dole carried the idea further in a book called Habitable Planets for Man, later paired with science fiction writer Isaac Asimov for a more approachable version. Their work arrived just as the wider world was turning its attention toward rockets, moons, and distant travel. Through the 1970s, the phrase Goldilocks zone began quietly circulating among scientists, borrowing its gentle warmth from that old children's story. It described one narrow truth, a region around a star where the temperature sits just right for water to remain in its liquid form. In 1993, astronomer James Casting and his colleagues built a careful climate model describing habitable zones around stars of differing warmth and brightness. Their work became a foundation that researchers still lean on today, long before anyone had confirmed a single planet beyond our own solar system. Since then, the idea has only grown richer. Researchers have proposed a wider galactic habitable zone too, asking whether certain regions within our galaxy might favour life more than others. A simple childhood story, it turns out, gave astronomy a lasting and remarkably useful word. Part 3. Where our solar system draws its own line. Our own solar system offers the clearest example of this gentle boundary, since it is the one place we can study up close. The Sun's habitable zone stretches out somewhere between Venus and Mars, with Earth resting comfortably near its middle, warmed just enough to keep its oceans flowing. Venus lies nearer the Sun, and its thick blanket of an atmosphere traps so much warmth that its surface grows hot enough to melt certain metals. Whatever water it may have held long ago has long since slipped away into its sky, leaving behind a dry, scorched world. Mars sits further out, cooler and dimmer under a thinner, quieter sky. Water there survives mostly as ice, tucked beneath its dusty ground, or resting at its frozen poles. Some researchers believe Mars once sat more comfortably within the zone, with rivers and shallow lakes across its surface. Earth, meanwhile, rests at a distance that keeps its oceans liquid across nearly its entire surface. Add our thick, protective atmosphere and a magnetic field shielding us from harsh particles streaming outward from the sun, and the picture becomes clearer. Distance alone never tells the whole story of a world. It is worth remembering that newer calculations have shifted these boundary lines slightly over the years as scientists refine their climate models. Some recent figures place Earth nearer the inner edge of the Sun's habitable zone than once thought, a gentle reminder that these lines are still being drawn. So even within our own small neighborhood, 3 worlds show 3 very different outcomes from 3 different distances. One too warm, one too cold, one gently balanced between them. It is a small, quiet lesson we carry with us as we look towards stars far beyond our own. Part 4. A world nearly the size of our own. In April of 2014, astronomers using NASA's Kepler Space Telescope announced something new: a rocky world close to Earth's own size, circling a dim red star nearly 500 light-years away. They named it Kepler 186f, and the discovery felt like a quiet turning point. This small world was the 5th and outermost planet found circling its star, with 4 others crowded closer in. Kepler 186f itself takes about 130 days to complete a single orbit, moving through its sky at a gentle, unhurried pace compared with our own year. What made this world so notable was its size. Earlier candidates found within habitable zones tended to be far larger than Earth, sometimes 40% bigger or more. Kepler 186f, by comparison, measures only about 1/10 larger than our own planet, remarkably close to home. Sitting near the outer edge of its star's habitable zone, this small world receives only about 1/3 of the warmth that Earth gathers from our own sun. Standing on its ground at midday, its dim red star would look no brighter than our own sun does an hour before sunset. Its star, a cool and modest red dwarf, is smaller and far dimmer than our sun, which pulls the entire habitable zone inward, closer to the star itself. Because of this, Kepler 186f orbits much nearer its star than Earth does, yet still finds itself gently, carefully warmed. We still do not know its mass, its air, or whether water truly rests upon its ground. At nearly 500 light-years away, it remains far too faint for today's instruments to study closely. Even so, its discovery proved something quietly important: that worlds like ours exist elsewhere too. Part 5. 7 small worlds around one small star. Not far from Kepler's find, another discovery offered something even richer. Circling a small, cool star known as TRAPPIST-1, astronomers found 7 rocky worlds, each close to Earth in size, tucked together so tightly they could all fit within the orbit of our own Mercury. The star itself is barely larger than Jupiter, a dim, patient point of red light resting about 40 light-years from Earth. Because it burns so quietly, its habitable zone sits close in, wrapping tightly around the star rather than stretching outward the way our own sun's zone does. 3 of these 7 small worlds, given the letters E, F, and G, orbit within that gentle, habitable band. Scientists using NASA's Spitzer telescope and later the James Webb telescope have studied their sizes and densities closely, finding worlds strikingly similar in weight and makeup to our own Earth. Because they circle so near their star, most of these worlds likely keep one face turned permanently toward it, much as our own moon always shows Earth the same familiar face. One side may bask in constant daylight, while the other rests in a long, unbroken night. This close arrangement raises real questions about whether water could survive there at all, given how near these worlds sit to their star's light and its outbursts. Yet researchers remain hopeful, noting that even the planets just outside the strict habitable band might hold water under the right conditions. The TRAPPIST system remains one of the richest places we know of to keep searching, with 3, possibly 4 small worlds gathered so closely together, all roughly the size of our own planet. It offers scientists a rare and valuable laboratory for studying how such worlds might hold water. Part 6. Our Nearest Neighbor and Its Watchful Star. In August of 2016, astronomers confirmed a rocky world circling Proxima Centauri, the very closest star to our own Sun, resting just over 4 light-years from Earth. They named it Proxima b, and its closeness alone made it instantly, quietly remarkable among every other find. Proxima b completes a full orbit in only about 11 days, circling far nearer its star than Mercury circles our Sun. Yet because Proxima Centauri is such a small, dim red star, that close orbit still places the small world comfortably within its narrow, gently warmed habitable zone. Its mass sits close to Earth's own, suggesting a rocky, solid world rather than a puffy ball of gas. Researchers found it not by seeing it directly, but by watching Proxima Centauri wobble ever so slightly, tugged back and forth by the small world's steady gravitational pull. Yet Proxima Centauri is a restless star, prone to sudden flares that can brighten it dramatically within moments. These flares send strong bursts of ultraviolet light and other harsh radiation outward. And because Proxima b sits so close, it may face far more of this than Earth ever does. Some researchers calculate that Proxima b receives dozens of times more ultraviolet radiation and hundreds of times more X-ray radiation than our own planet gathers from the Sun. Whether any atmosphere could survive under such conditions remains an open question, one researchers continue turning over carefully. Even with these open questions, Proxima b holds a special place in this search, simply because of its nearness. It is the closest known world resting within any star's habitable zone, close enough that future telescopes may someday study its sky directly, rather than only imagining it from afar. Part 7. Red dwarfs offer time and take their toll. Most stars scattered through our galaxy are small, cool, and dim, known as red dwarfs. They burn their fuel so slowly and gently that they can shine for trillions of years, far longer than stars like our own Sun, offering their worlds an enormous stretch of steady time. This patience makes red dwarfs appealing places to search for habitable worlds. A star that burns gently for such a long stretch gives any nearby world ample time for water to settle, for an atmosphere to steady itself, for whatever chemistry might unfold to unfold slowly and thoroughly. Yet, these same small stars come with real challenges for the worlds circling them. Because they burn so dimly, their habitable zones sit close in, and worlds there often become tidally locked, always showing one face to their star, much as our own moon always faces Earth. Red dwarfs are also known for flaring, sometimes dramatically, especially early in their long lives. These outbursts send strong bursts of radiation outward, and a nearby world may face this again and again over its history, its thin atmosphere slowly worn away if it cannot hold steady. Researchers continue studying how a magnetic field, a thick enough atmosphere, or a deep ocean might help a small world weather these outbursts and keep its water intact. It is a careful balancing act, weighing a star's long, gentle life against its occasional bursts of harsher energy. So, a red dwarf offers both a gift and a trial. Enormous time to work with, paired with real tests along the way. Whether any small world circling one of these patient stars has found a way through both remains one of the more fascinating open questions in this search. Part 8. Other paths to water beyond the zone. The habitable zone gives astronomers a useful starting point, but it is not the only place water might rest. Closer to home, several moons circling Jupiter and Saturn sit far outside our Sun's habitable zone, and yet researchers believe deep oceans rest quietly beneath their frozen, icy shells. Europa, one of Jupiter's larger moons, likely holds a salty ocean beneath a shell of ice, kept liquid not by sunlight, but by the gentle, steady squeezing and flexing caused by Jupiter's powerful gravity as Europa moves along its orbit. Warmth here comes from movement rather than starlight. Saturn's small moon Enceladus offers something even more striking. Plumes of water vapor and ice spraying outward from cracks near its southern pole. These plumes suggest a hidden ocean resting beneath its icy crust, one that spacecraft have already flown through and gathered readings from directly. This kind of warmth, born from gravity's gentle squeezing rather than a star's light, is sometimes called tidal heating. It reminds us that a world's distance from its star is only one piece of a much larger puzzle, and that water might rest in places we would not first expect. If moons within our own solar system can hold hidden oceans this way, it stands to reason that similar moons might circle distant worlds too, tucked quietly around gas giants far beyond our own sun's habitable zone. Such moons remain difficult to study, but far from impossible to imagine. So, while the habitable zone remains a useful, gentle guide, it is only a beginning. Water, it seems, finds more than one path through this galaxy, resting sometimes in starlight's gentle warmth, and sometimes in the quiet, steady squeeze of a nearby planet's pull. Part 9. A small world with water in its air. About 124 light-years away, a world known as K2-18b circles a small red star, sitting within its narrow habitable zone. Larger than Earth, but smaller than Neptune, this small world has drawn steady attention from researchers for nearly a decade now. Early studies using the Hubble Space Telescope suggested water vapor within its thick atmosphere, a finding that quietly raised hopes among researchers hunting for signs of habitability. Later work using the James Webb Telescope added methane and carbon dioxide to the picture, deepening both the interest and the debate. Some researchers have proposed that K2-18b could be what they call a Hycean world, a thick hydrogen atmosphere resting above a deep global ocean of liquid water. If true, this would offer an entirely different kind of habitable world than the rocky ground we picture on Earth. Other researchers studying the same readings suggest a simpler picture instead, a gas-rich world without any solid surface or ocean at all beneath its thick atmosphere. The evidence, so far, allows both stories, and scientists continue gathering readings to narrow down which picture fits best. There have even been tentative hints of a gas called dimethyl sulfide, which on Earth comes mostly from ocean life, though this finding remains far from settled and needs far more careful study before anyone draws firm conclusions from it. Science here moves carefully, one gathered reading at a time. Whatever K218b turns out to be, it shows how far our tools have come. Not so long ago, simply confirming a world's size felt remarkable. Now we study the very gases drifting through a distant world's sky, searching gently for whatever quiet story that sky might tell us. Part 10. What comes next in this quiet search? Every world we have visited tonight, from Kepler's small find to the 7 worlds circling TRAPPIST-1, from our nearest neighbour to this small water-rich world further out, shares one thread. Each sits, however roughly, within that gentle band where water might remain liquid upon its surface. None of them have proven beyond doubt that they hold water, let alone any form of life. What they offer instead is possibility, a growing list of worlds worth watching closely as our instruments continue to sharpen and improve over the coming years and decades ahead. The James Webb Telescope continues studying several of these worlds directly, reading the faint fingerprints left behind in starlight as it passes through a distant atmosphere. Future telescopes, still being planned and built, promise to look even closer, gathering fainter light from worlds further and further away. Astronomers are also refining their sense of habitability itself, moving past simple distance and water alone, toward richer questions about magnetic fields, atmospheres, and the steady behavior of a star over long stretches of time. The picture keeps growing more careful, more layered, and more complete. Somewhere among the countless stars scattered across our galaxy, a great many worlds likely rest within these gentle bands, waiting quietly for our instruments to grow sharp enough to notice them properly. We have found dozens already, and researchers expect that number to keep climbing steadily. For now, we simply keep watching, keep gathering light, keep listening patiently to whatever these distant worlds might tell us. It is slow, careful work, built one small discovery at a time, and there is something deeply soothing in knowing that this quiet search will simply keep going. And on that note, we have drifted tonight from our own sun's gentle boundary lines all the way out to small, water-hopeful worlds circling stars far beyond our own. We have met a modest planet found by Kepler, 7 small worlds gathered close around one patient star, and our very nearest neighbour, watched over by a restless little sun. We have also wandered past the strict edges of any habitable zone, toward icy moons warmed by gravity alone, and toward a small, distant world whose sky may or may not hold the fingerprints of an ocean below. Each of these worlds reminds us gently that the universe rarely settles for one single answer, favouring instead a wide and patient range of quiet possibilities. Thank you so much for joining me here tonight, drifting together through these small, distant worlds and their careful, gentle balances. Rest now, knowing that somewhere out there, countless stars keep their own quiet watch over worlds we have not yet found. Until next time, keep looking up.